Another piece of terminology we need to know about is the homologous series. So this is when we're talking about organic compounds, things that belong to the same group or family. So, you know, we've got the alkane family, the alkene, the alkynes, halogens, alcohol, aldehydes, ketones, carboxylic acids, amines, esters, and amides. That's a lot to take in right now. These are the ones we need to know about. There are others. There are lots of others. All the compounds in the same group or same family will have the same general formula. For example, alkanes all have CnH2n+2. They will have trends in their behaviour. So, for example, the longer the chain, the higher the boiling point. All of them will have similar behave similarly in chemical reactions in terms of all alkanes will have a similar behaviour, but as the group gets bigger, obviously they're going to have different physical properties. And each of the different families have different physical properties. So alcohols are significantly more soluble than aldehydes, for example. However, the exception to that rule is it's dependent on the size of the chain. So the ratio of the carbon chain to the polar group. Alright, yet again, some more terminology we need to know. We need to know about saturated, unsaturated, and aromatic compounds. We need to know what it means, really. And so if we think about saturated compounds, they only have single bonds. So that'll come back to our alkanes. Our unsaturated, they have a double bond, at least one, they could have multiple, or a triple bond. So we can see here in these aromatics underneath, which is anything that has a ring as part of it, so something that's joined up. In this case, we've got benzene. And we can see here that they've got double bonds in here. And toluene, also an aromatic, has double bonds. Let's take a look at naming. So let's recap what we need to know about naming. Alright, so in terms of systematic nomenclature, which is a fancy way for saying naming organic molecules, we need to have a look at whether or not there's any functional groups, because this makes a difference to its physical and chemical properties. So we need to be able to identify these groups, and we've gone through the list of what we need to identify. We need to be able to name them. So we need to have up to 8 carbon chains, either straight or branched, and we need to be able to look at it one or more functional groups. So the only limit to this, so hydroxyl groups, we need to be able to know primary, secondary, and tertiary alcohols. Aldehydes, they're only terminal. But with our amino group, we only need to know primary. We also need to be able to give a systematic name if we can see a structure, so we need to be able to name structures, and we need to be able to name esters as well, and draw or deduce what an ester is made from.